Welcome to the demo. We are going to build a loan application analysis model using Amazon SageMaker Canvas. In the demo, we'll showcase how to prepare data, train models, and collaborate with ML project teams effortlessly without writing a single line of code. Let's kick off data preparation using SageMaker Data Wrangler, a service streamlines data analysis, aggregation, and transformation for ML. We may create a data flow in Data Wrangler so as to define a series of ML data analysis and preparation steps. To create data flow under Data Wrangler view, we may click Import and Prepare button to import tabular dataset. Under Import Tabular Data view, besides Canvas dataset, there are more than 50 data sources being supported, which is pretty handy to support your business data analysis. We will use two datasets in our use cases. They are Canvas sample loans part 1 and with loan details, and Canvas sample loan part 2 with applicant detail. Select loan detail Canvas sample loan part 1 dataset and click Next button. As we see, ID column is the key for loan detail dataset. Click Import to create a data flow. Once getting into data flow view, let's import applicant details dataset. Add data and then select Canvas sample loan part 2. In the data previewing window, we notice ID column is the key mapping to loan detail dataset. Let's click Import button to add the data flow. Now, both datasets are added in data flow. We may combine them to create a unified dataset. Click Dock button nearby loan detail dataset. Then select Join Actions from Combine Data menu. And then click Loan Applicant dataset to complete the data join setting. Accept default configuration for inner join. Once the join action is done, we are good to go. Next, we will leverage building analysis tools to check data quality, identify potential target leakage, and gain valuable insights. Let's create the first analysis, data quality and insight analysis, which summarize data statistics, feature impact, and quick modeling evaluation. Select Get Data Insight menu. On the Join Data, accept the default analysis type and enter the name. It is a classification problem, and the target column is loan status. Target column is the one we want to predict for our business problem. Once confirmed, Data Wrangler can generate analysis quickly as our dataset is small. Around some seconds, the analysis report is generated. At the top, it provides data statistic insight. Next, we notice a high priority warning is generated per quick modeling evaluations. It advises that we need to clean the data and transform the data to be useful features for model training. We may ignore it as we are going to use AutoML services for model training and leave the service to figure it out. There are two callouts, and we may tackle them in the data preparation step. The target column is imbalanced, especially about 75% of the records are with fully paid in target columns. Under feature summary sections, there are some columns with zero prediction power for the target columns. For example, ID, issue on, and derogatory public records. We may drop them later. Next, let's get back to data flow view. We want to showcase how to check for data preparations, which leverage generative AI for natural language-based data analysis and preparations. as check service is backed by Anthropic Claude foundation models in Amazon Bedrock. We need to apply the related model access in Amazon Bedrock first. Now use check for data prep services. Imagine we want to understand whether applicants have high income, may have higher chance to pay off their loans. Let's ask for that. Plot a histogram on annual income grouped by loan status. It generates a histogram to bin annual income values and colors loan status across each bin. Interestingly, in the dataset, for those annual income over 120K, applicants may have higher chance to pay off the loans or pay the loan on time. We may save the analysis to review later. Let's park it for now. Next, let's remediate two quartiles from data and insight analysis report. First, let's drop columns which have no predictive powers. Rather than writing code to manipulate the dataset, let's send this request. Drop ID columns and drop issue on and derogatory public records columns. The service may describe what actions it takes and share related code on how to. Especially, it presents a preview on dropping columns. Let's accept the suggestion with clicking Add Step button. Once the step is added to the data flow, the data processing will be accomplished and the columns are removed. Let's name the step Drop Low Prediction Power Columns. Next, we care about whether the loan can be fully paid. We may merge the minority classes charge-off and current together. Input this request. Replace charge-off and current with default for column loan status. As we see, the values being changed to two classes. Let's add the step and name it to simplify the loan status column. Besides using natural language to instruct the service, we may use built-in data transformation feature. For example, as the dataset is imbalanced, we may use balanced data transform. We can key in balance to search the functions. Balance data. For now, we don't do so in the demo as we may leave it to model building. Let's get back to the data flow view now. I would like to highlight that the data flow can be exported via Jupyter Notebook, integrating to other SageMaker services, such as pipeline for data processing and inferencing, and exporting the dataset into SageMaker Feature Store or S3 storage. With that, ML project teams can reuse the exported data flow and datasets. Now we are good to go for model training. Usually, a good model building process is iterative and may require solid ML skills on experimenting feature engineering, like transforming data to be useful features, ML training algorithm experimentations, and model tuning. However, with SageMaker Canvas, we may delegate such tasks to SageMaker Autopilot services, which is a feature set that simplifies and accelerates automatic ML training. Click Create Model side menu on the last step. Before model training, we will need to export the data to Canvas. Let's name the dataset as loans. Once the dataset is created, click Create Model link in the pop-up notifications. In Create New Model pop-up window, it allowed us to choose a recipe for our ML problem. We shall use predict analysis, as we are tackling classification problem for loan status. Moving to model building configurations, we may select loan status as the target column, then click Configure Modeling to do further configurations. Let's have a quick look. Two-category model is the default selection, given there are only two types of value in loan status. It's a binary classification problem. For data split, we may set up the percentage of training and validation data set. Let's keep it as default. Then we may click Standard Build to kick off the model building. It begins with data validation and kicking to model building process, which may take up to 45 minutes. Given our data set is small, you should be able to finish earlier. As you may see, without ML expertise or writing code, I will kick off model training process, and SageMaker Autopilot services will work out the best model candidate for me. Now let's pause and wait until the training finished. Now the model training has been completed successfully. Let's have a look at the model performance analysis. Under the Analysis tab, there are two metrics being listed: accuracy and F1 score. F1 score is the optimization metrics being used for model training. On the other hand, accuracy metrics is over 77%. It means the model predicts correct loan status 77% of the time. Given our data set is small and imbalanced, the model performance is not bad. Especially without doing any ML experiment, we already have a good baseline model for loan application analysis problem. In the Overview tab, it showed us the column impact for each column. Column impact is a percentage score that indicates how much weight a column has in making predictions in relation to other columns. The main purpose of column impact is for model explainability. We may use domain knowledge to verify whether the model makes sense. For example, we can ask business, does long-term impact applicants the most regarding paying off the loans? The discussion may help us prepare data and may train better models. In Scoring tab, the service evaluation model per validation dataset. That is a Sankey chart to illustrate how the predicted result and connections to the actual result. The chart helps us understand the model performance. For Advanced Metrics tab, it provides detailed analysis on model performance with useful ML metrics. Especially, it allowed us to choose positive class in the classification problem, which makes our life easier to analyze model performance on our business problem. One quick highlight is that AUC-ROC score is 0.783. AUC score is about how well the model may classify classes. The result is good, given we are working on such a small data set and imbalanced data. One more, learning and interpreting model performance metrics is an important way to use ML to solve business problems, and I highly recommend to spend time on learning that. Moving to Model Leaderboard, it lists the model candidates and their ML performance and inference latency metrics. Especially, the best candidate is the one with highest F1 score, the optimization metrics, and is set to be default model, which SageMaker Canvas use for model predictions and deployment. On the other hand, we may view other candidates and may change them to be default models. Next, We want to get model prediction for actionable insights. Clicking Predict button or Predict View. There are two options for predictions, batch or single predictions. Batch prediction allowed us to get prediction by batch, and you may do so manually or automatically when there is a data update on your specified Canvas dataset. Single prediction is very handy for us to evaluate long applications, and we can get immediate result from the service. To run model predictions at scale, we can deploy the model. Hopping to deploy view, we can create model deployment using SageMaker Inference, which allow ML project team to use API to get prediction result from our trained model and may conduct further evaluations. Besides deploying model, we can collaborate with ML project teams with sharing the model. Let's move to model version view. We can click Add to Model Registry menu from the model versions, which may allow us to share the model with ML project team via SageMaker Studio. Let's do so and set up a model group name, Canvas Loans Model. To see how the collaboration works, let's move to SageMaker Studio to have a quick look. SageMaker Studio is an ML purpose-built cloud IDE with integrations to SageMaker services, such as experiments, ML pipelines, and model registry. To view the registered model, select Model Menus. We can see that a model group, Canvas Loan Model, is listed, and there is a model version under the model group. Now we are going to illustrate a human-in-the-loop activity in ML process. As a data scientist, I wanted to view the model candidates from model registry, evaluate its performance, and may accept or reject it so as to trigger downstream tasks such as model deployment or email notifications to the team. Select Model Versions and click Evaluate tab. You can evaluate model performance via viewing the metrics and the chart. We can deploy the model to evaluate new test dataset or may update model status. To update model status, click drop-down button under Deploy tab. We can approve it and it will trigger an event in EventBridge service, with which can be used to set up downstream tasks to deploy the model in a testing environment. Overall, this collaboration process involves a governance workflow for ML project teams to review models and provide feedback, which is a very effective way for business user and the team to improve model quality together. Our demo is completed. As we can see, use Amazon SageMaker Canvas to prepare data, drive best model candidates, and collaborations with ML project team is a very useful way to deliver business outcome. Without writing a single line of code, we can train best model and solve business problem easily and quickly. Now let's get back to the presentation.